In the previous video, we were introduced to Archimedes' principle. Now we will take a look at how to solve some problems using Archimedes' principle. First, we have a metal anchor that weighs 81 pounds in air and 68 pounds when underwater. We want to find the buoyant force of the water. In the previous video, we saw the equation we can use to solve for the buoyant force. The buoyant force is equal to the weight in air minus the weight in water. The weight in air is 81 pounds, and the weight in water is 68 pounds. Substituting both of these numbers and subtracting, we see the buoyant force is 13 pounds. In this example, we have a metal casting that displaces 2.12 cubic feet of alcohol. We want to find the buoyant force of the alcohol. We already mentioned in the previous video that the buoyant force is the same thing as the weight of the displaced alcohol. Therefore, we need to find the weight of this displaced alcohol. We can find the weight by taking the volume of the alcohol displaced multiplied by the weight density of the alcohol. The alcohol displaces 2.12 cubic feet, and the weight density of alcohol is 49.4 pounds per cubic foot. Multiplying, we see that the buoyant force is 105 pounds. This concludes our discussion on hydrostatics and Archimedes' principle.